Hey guys, still your favorite Speed Math with Promise. On today's episode, we are going to be discussing the following. Still under complex analysis, please. I need you to pay massive attention. Okay, so we're going to be discussing analytic function, harmonic function, Laplace equation, Cauchy Riemann's equation. So to start with, I want us to start with analytic function. From the word analytic, a function is said to be analytic if it satisfies a particular equation, okay, or condition. So looking at this, which of the following would help us to depict a particular function which is actually analytic? You know, sometimes by mere looking at something, you may not know if it is the way you were thinking it is. So a function is said to be analytic if it satisfies Cauchy Riemann's equation. It's as simple as that. If you are asked to explain and you don't know how to explain analytic function, that's exactly what you should say. So what is Cauchy Riemann's equation? Now, Cauchy Riemann's equation is an equation that is used to analyze an analytic function, or that is used to depict whether a particular function is analytic or not, okay? Specifically, a complex function. Now, let's look at a complex function such that we have the real part plus we have the imaginary part. Oh, sorry, I'm missing something, V. I'll still explain what this U and V represent, okay, at the end of the day. So just pay massive attention. So this is a function of a complex number, and then we want to what? We want to explain Cauchy Riemann's equation, what it has to do with what, or what exactly Cauchy Riemann's equation has to do with analytic function. So let's see that. So for you to be able to depict analytic function, you have to what? You have to be able to understand Cauchy Riemann's equation, which is to say that this is the real part and this is the imaginary what? Imaginary part of this function, of this complex function, because of it is a complex number. But then by the time you find the first derivative with respect to x of this real part, it should be equals to the first derivative with respect to y of this imaginary part. You can see that I'm using the u and the v respectively. That is it. And also, by the time you find the first derivative from this same part with respect to y, okay, these are what you are going to be doing. Then later you compare and contrast. So it should be equals to, when you find what, it's going to be equals to the negative of when you find the derivative of what, of the imaginary part with respect to x. So this is something you should have at the back of your mind. With this, you can be able to depict what? You can be able to depict whether a particular function is analytic. I'm still going to discuss others, but let's take one particular example, okay? Let's take an example. I have one example here to clarify this. So please, if you understand this, drop in the comments that I already understand what Cauchy Riemann's equation is all about. It's as simple as this. And also tell me in the comments that you already know what function exactly it is used to prove, or what function it satisfies. Let's look at this question. Okay, now let me just write the question. I was not supposed to write this question, but I'm going to make it succinct. So the function z, the function of a complex number 2x plus 1 then y plus I into y squared minus x squared minus x. Now they are not asking us, they say, does f, okay, does f satisfy Cauchy Riemann's equation? Cauchy Riemann's equation, meaning in a way they are asking us to check if this particular function, or if this particular equation, or will I call it function, is analytic. Because if it does satisfy Cauchy Riemann's equation, then it is what? Analytic. Okay, so let's see how to do that. So I remember telling you, okay, first of all, let's tell ourselves what this is and this is. Okay, what this is and this is. This is the real part. So our u is actually 2x plus 1 y, right? And our v is what? Forget about the I is just to depict the imaginary part. Y squared minus x squared minus x. Please pay attention. This thing is pretty easy. If you pay attention, you will get it. So now, all we have to do is to follow that formula. We said our first derivative of what? With respect to x from the real part, because this is the real part and this is the imaginary what? Part, right? So it must be equals to the first derivative with respect to y from the what? Imaginary part. From the real part must be equal to that of the imaginary part. But we're still going to compare and contrast, but we have to check all of this. Then first derivative with respect to y from the real part. If you see u, just know that u has to do with what? The real part. And then is equals to minus first derivative from the imaginary part. If you see v, just know that it depicts what? The imaginary part of that complex number. Okay, now, oh sorry, x. Okay, I said I was going to tell you what u and v represent. U and v actually represent the imaginary, or will I say this part and this part, which is u and v, represent what? The real and imaginary part, right? And apart from the fact that they represent the real and imaginary part, they are also harmonic. Okay, in the case whereby it is analytic, it's an analytic function, and it has been able to, or it was able to satisfy Cauchy Riemann's equation. The real part and the what? Imaginary part are what? Are harmonic. Okay, we are still coming to harmonic function. Just step down, get your pen, and please take note of all of these things. They are very expedient. Now let's go right into the solution. So we've been able to itemize the real part and the what? Imaginary part respectively from our u and our v. Now it's now time for us to evaluate. We say I'm going to find the first derivative with respect to what? X. Let us open this bracket. So opening this bracket now, 2x multiplied by y will now be what? 2xy, right? 2x multiplied by y will now be what? 2xy, right? Plus, if you multiply this, 1 times y is y. So we have been able to do this, and then this will still be the way it is. Removing the bracket does not really mean anything, because there's nothing outside for you to expand the bracket with. Okay, I think this is better. Okay, differentiate u with respect to x on the first hand. So when you do that, this one, you're not doing anything with y, so that one is gone. This is 0. So if you differentiate with respect to x here, if you differentiate this, you get what? If you differentiate this 2x, okay, pay attention to 2x. If you differentiate 2x, what will you have? You have what? You have 2, right? Because you are going to minus 1. So that 2 multiplied by y will give you what? 2y. So now, okay, we said after doing u substitute x, we want to check if it is equals to this. Okay, so we have done this now. So let's do v subscript y, which is differentiating v, which is the imaginary part with respect to y. Let's see. Okay, so from here, let's do that. If we differentiate, remember we are paying attention to what? To y. If we differentiate with respect to y, that means whatever consign that is not related to y or that is not combined with y is going automatically, right? So that means this one, we are not paying attention to this x as well, we are not also paying attention to this. So that means this is the only thing we are paying attention to. If you differentiate y squared, you get what? 2y. I'm already seeing their congruency here. So moving on, we want to do u subscript y, which means differentiating the real part with respect to y. So you come back to this real part. Remember, this is the modified version. Remember, you are paying attention to what? To y. So if you pay attention to y, this is what it's going to be. If you differentiate this with respect to y, remember you are not paying attention to x, right? If you differentiate, okay, just come to your y, differentiate y. Y is on its own. You differentiate y, you get what? You get 1, right? Remember, it's with respect to y. That means you'll be left with 2x. So 1 times 2x is 2x. Then if you differentiate y here, you get what? 1. That is it. Now, anytime you differentiate an alphabet that is on its own, you get 1. So the next one is what? V subscript what? X. But this time around, they say we should put minus because that is what the formula states. Okay? So that implies that whatever we're going to do here, we're going to still multiply all through by minus. Let's see. Okay? Now, from the look of things, we're already seeing that this one is equal to this. So we are left with this. We have already checked this indirectly. So we are left with this and this. So if we check this and it's equal to this, bam, that implies that it satisfies Cauchy Riemann's equation. But let's continue. So going to the imaginary part, remember V is the imaginary part. So going forward to the imaginary part now, remember we are paying attention to what? X. Differentiate with respect to x, meaning we are not going to pay attention to this. The only time you will be paying little attention to that particular variable is when they are attached together, okay? But this time around is on its own. So this thing you are not paying attention to, so it's automatically 0. So this is what you are paying attention to. So remember, this minus belongs to this x. So if you differentiate minus x squared, you get, normally if you differentiate x squared, you get 2x. But due to this minus, it's going to be minus 2x, right? Then minus, if you differentiate x, you get 1. I told you anytime you differentiate a particular variable standing on its own, you get 1. So in this case now, if you decide to multiply all through by minus, thereby changing all the minus to plus, you can see that you have the same thing here. So this implies that this one also what? Holds. And in conclusion, we can now see that truly this particular function satisfies what? Satisfy Cauchy Riemann's equation. We're going to be solving more questions, but let's move to harmonic function, okay? And in this case, it is what? It is an analytic function. You see it? In this case, we can now say that this particular function of a complex number is what? Analytic, because it does satisfy this condition. What is the condition? Cauchy Riemann's equation, okay? The Cauchy Riemann's what? Equation. So let's move to harmonic function. So let me clean this. Please pay attention. These things are very easy. Please, if you have any question, kindly drop it in the comments, okay? Please ask your questions. I may make another video to reply your question, okay? I'll do another video rather to reply your question. But then let's move forward. Please, if you are seeing this channel for the first time, do well to subscribe to this channel, okay? And if you have watched this video to this very end, I'm really grateful, honestly. Please share with your friends and your colleagues so that they can take part. They will enjoy this video as well, because I believe you're enjoying this video. So let's move on to harmonic function. What is harmonic function? What does harmonic function entails? What exactly can we use to depict harmonic function? You can see that we have a particular equation left there, and that is the Laplace equation. Harmonic function is a function that satisfies a particular condition, and that condition is with respect to what? Laplace equation, okay? So that means a harmonic function can be detected or can be depicted. Sometimes you may be asked a question, which of the following is an example of, or which of the following is not a harmonic function, right? You should be able to depict. If you are not able to look at it and tell, you should be able to know what your Laplace equation is all about, and then use your Laplace equation to determine if that particular function is what? Harmonic. Now let's move on. So harmonic function, since we say that it's what? It tells us more, or it is the Laplace equation that satisfies harmonic function. So let's pay attention or close attention to Laplace equation. So what is Laplace equation? Laplace equation is almost like the Cauchy Riemann's equation, but not exactly. For Laplace equation, you are going to be differentiating twice, okay? Okay, if you are paying attention to the what? To the real part, you are going to differentiate twice with respect to x, then you differentiate twice as well with respect to y, and then by the time you sum the two derivatives, okay, the two derivatives squared, that is, haven't done twice of each of them, then by the time you add it together, you must get 0. So in this case, it's regarded as harmonic function, okay? And the harmonic function has something to do with analytic function. Like I said earlier, that the imaginary and the real part are harmonic when that particular function is actually what? Analytic. And that's when you have been able to determine that it actually satisfies Cauchy Riemann's equation. Simple as that. So let's continue. So let's solve question on this actually. So we can actually remember, if you see u actually depicts the real part. Then if you see v, you can equally have v xx plus v yy equals to 0. So depending on the parts that you actually want to focus on. But let's see how to do this. First thing first, you will have to, let's rewrite. So remember that if you see z, you know what it represents, right? That z is actually x plus I, y. I have taught this in the previous class. This is what? A complex number. Then square. minus 2z, and the z still represents what? X plus I y, right? So in this case now, remember that the v part is mostly what is actually regarded as the what? The imaginary part. So first of all, I have to resolve this. I have to put the imaginary part separate and put the real part separate. It's as simple as that. So let's do that. So let's resolve this. For us to resolve, you know what it is. If you have not learned how to do this thing fast, check my short videos. You learn this. This is x squared, right? X times iy times 2. That will be plus. Remember this plus. Because of this plus, you put plus 2 xiy. Okay. See that? Then I squared is actually minus, right? I squared is actually minus 1. So you put your minus, then y. You see that? Very easy. But if you want to expand, you can expand it opening two brackets. But don't forget that I times I is minus what? 1. So minus, open this, 2x, minus times plus, minus 2iy. Okay, now, remember, my sole aim is to resolve this such that I'll put the real part and the imaginary part and then focus on the what? On the imaginary part, because I told you that this is the imaginary. The v is actually the imaginary, like I said earlier. So in this case, let's see how to do this. So focusing on the imaginary part, right? So I want to focus on the imaginary part. Let me just pick the imaginary ones, right? So if I pick this, remember I'm to put my eye outside, right? When I put my eye outside, what will I have here? I actually have 2xy, right? Minus 2 what? Y. So the real part is actually x squared plus y squared, sorry, s squared rather. S squared minus y squared, where is it? Minus 2x. I have nothing to do with it because this is the u part. So I just have to focus on the v part. As simple as that. So let's focus on the v part because that's exactly what I was asked to do. So I'll find the first derivative and also the second derivative. So where should I do this? Okay, let me do it on this part of the board. Please, this one is for Cauchy Riemann's equation, which is used to test analytic function, but we're looking at harmonic function. So this is what we want to depict if this is harmonic function. Okay now, and remember, harmonic function, the real part and imaginary part are harmonic if that particular function is what? Analytic. Okay, so let's see. Now focusing on this part, remember, let's do for the first derivative. So for the first derivative, differentiate, remember, it's with respect to x that they told us. So focus on only with respect to x. So differentiate x here, you get 1. So you'll be left with 2y. This one is 0. So that means 2y, right? Then you come again. And then you differentiate what? X again, right? So please pay attention. You have differentiated x, so you have to differentiate x again. So to differentiate x this time. Now if you observe closely, there's no x again there, right? So in that case, since there's no x there, automatically it is 0. So our answer is A. So the correct answer is actually what? Option A. So you can see how simple this is. So I think I've been able to explain this. So if you see question, please do well to attempt questions, okay? So I'm going to be dropping questions in my community post. Please do well to attempt those questions because they are going to be very, very simple since I've been able to explain this. And if you have any other question to ask me, drop it in the comments. I'm going to be answering all your questions. Thank you very much for watching to the very end of this video. Please do not forget to share this video, very important. And then see you in my next video. Peace out.